Hi there everyone, welcome to the Journeying Programmer. Today we'll be working with images in Python and using the pillow package, so enjoy. Alright, so the first thing we're going to want to do is install pillow package. I've already got it installed, but all you'd really need to do is go into your terminal. For me it's just Command Shift tilde. So then we'll type in pip, in this case pip3, install pillow. For me it's pip3, you might be fine with just pip, see whichever one works for you. I've already got it installed, which is why it's giving me this message here. Otherwise it'll go ahead and install the package for you. Once that's complete, we'll want to import pill. Actually wait, sorry, from pill import image. Yep. Because we're working with files, I usually like to wrap my code inside try and accept, so we'll do that now quickly. The type of error that we'll be getting is an IO error usually, so I'll just want to print something to the console just to say, hey, this file could not be read. Okay, so the first thing we'll try to do is open an image. So the image that I'll be working with is just a bit of an image of myself, just a PNG. So what I'll do is I'll go image equals image.open, and then you want to pass it the path to that particular image. So in this case, portrait PNG. Just as a bit of a check, I'll print the size of the image to the console. And you can access the size of the image through the size attribute on the image. So if we run that, that should print us, return us the width and the height as a tuple. Yep, so 1280 by 853. We can actually check that if you wanted to. You can just check the info on the image. And we've got the dimensions here, which says 1280, 853. You can do the same thing on a Windows. It'll be a slightly different interface, but yeah, you can confirm that through that as well. So good news, we're getting the image. We're actually able to read it. You probably want to do more than just read an image, or open an image, I should say. You'll probably want to be manipulating it as well. So we'll cover a few use cases. So if, we'll go convert. You might want to get a thumbnail. And we'll try crop as well. Alright, so I'll just put this into a function, so convert. We'll pass in the source image. So source image of type image. And we'll also pass in the format, just type string. And we'll do whatever conversion logic we will inside the function, and we will return an image. Alright, so we'll use a match case on the format. So we'll say case JPEG. I'll leave it at JPEG just because it's easy, just an example. But if you wanted to, you could potentially have more cases, for example, TIFF or BMP as other formats. So what we'll want to do here is source image dot convert RGB, and then we'll want to return that image. Alright, so let's give that a try on our image here. So we'll create a new variable called converted image equals convert, pass in that image, our original image, and the format, which in this case is JPEG because that's all we've coded. So now that we've got that converted image, we'll want to save it. And now we'll just pass in the path. converted underscore image, and this time it's not a .png, it's a .jpg for JPEG. If this goes well, then we should see another image pop up in the images folder. Let's see what we get. We're not returning. This is a mistake. We're returning the original image, so that should work. Yep. Let's give that a crack. Yep. All right. Awesome. So now we have an image in a JPEG format. You can just confirm that, reveal it in Finder, and yep, the type is JPEG image. Okay, cool. So that's the first one done. Next, we'll try a crop. Def crop. Pass in the source image again. Type image. This time we'll be passing in. Actually, no, we'll not worry about the crop dimensions. We'll just hard code it directly into the method. I'll just leave this as a node. So left, top, right, bottom. Don't worry, I'll explain what that means just right in a second. We'll also be returning an image. Okay. So the crop function for pillar can be a bit confusing at first. It might take a little while to get your head around. So I've got this little image here that should help explain the concept of how crop works. So the reference point, the 0 point, will always be the top left of the image with coordinate 0, 0. Now, the crop takes a tuple as an argument, which is essentially left, top, right, bottom, which represent the top leftmost vector of the cropped image, and the bottom right will be these two here, which represent the bottom rightmost vector of the output image. So from here, and following the convention of this method here, left, top, right, bottom, what will happen is the first parameter, left, will be how many pixels from the 0 point here will we want to move. So we'll be going left 200, which can be a bit confusing because we're actually going right by the image, but we're talking about left, top, bottom, right in terms of the output image. So this is still the leftmost point of the output image. So 200 pixels from the original image. Now, same thing from the top. So from the top going down, 330 pixels, and we've got the XY coordinates. So next is the right, and this is the bit that's a bit confusing. It's not going from the right towards the left, it's going from the left toward the right still. So it'll be 700 pixels from the left-hand side, and then from the top, 606 pixels going down. That might take a little bit of practice to get used to. So we'll use an example right now. So we'll go return source image dot crop, and because we're passing in a tuple, I'll just add an extra parenthesis set inside. Also, it's a lot easier to understand if you work with the original width and height of the image. So I'll just deconstruct the size of the image into width and height equals source image dot size. Okay, so for the image, what we'll say is, so we want to pass in the left parameter first, okay? So we want it to be somewhere around here. So the way that I like to think of it is, look at the entire width of the image. So we'll say half is about there, a quarter is about here, which is a nice place to start, I suppose. So we'll say width divided by 4, okay, which should give us a vector of somewhere in this vicinity. Then from the top, okay, so we'll be passing in the top parameter. So in this case, we usually work with height. So we'll say half again should give it about here, which is about a quarter. I want it a little bit higher, so maybe I'll give it a fifth. Yeah. So I'll say the height of the image divided by 5, which should take us to about here, somewhere around here. So now we've got to pass in the right parameter. So you want it to be around here. Okay, so we've already worked with width divided by 4, which gives us 25% of the height, of the width. If you want to go here, we'll say about 75% of the way from the left. We'll do, so 3 times, I guess we could go width times 0.75, which would give us 75% of the full width. Okay. Then the bottom parameter. Okay. So if we want it to be around here, I think we'll say height times 0.8 times 0.8. Actually, it might be easier if we just work with multiplication instead. So times 0.2. Yeah, we'll do this times 0.25. Oh, that's not a point, that's an exclamation point. Times, okay, let's see what that does. Okay, so we'll go cropped image equals crop. We'll pass in the source image. No need to pass. We could pass in the tuple, but I figured for understanding it'd be easier just to hard code it directly in. Whoops! It's not called source image. It's called image. Sorry. Then we will save the cropped image. So dot save. We'll pass in the path images cropped underscore image dot png. Hopefully that'll work. Let's see what that does. Alright, so we've got a cropped image. Whether our dimensions were, it's not too bad. We've got most of the face, but that's essentially how you would crop. So there's the original. Actually, maybe if I just go like this. Yep, so on the left here, we've got the original. And then on the right, we've got the cropped image. Alright, so that was a success. Okay. One more example of what we might do and create a thumbnail. So the thumbnail works on an original image. It doesn't return, it has a return type of none, that method thumbnail, which is built into Pillow. So what we'll do is we'll create a copy just here in the try block. So image copy equals image.copy. Okay, so just so we can leave the original image unaltered. So now what we'll want to do is call image copy dot thumbnail. Then so it'll want us to pass in the size, which is again a tuple. So we'll put parentheses. I think 300 by 300 is a nice size. And we will call save. So we'll save that thumbnail image. So images, thumbnail underscore image.png. Okay, one thing to note about this thumbnail method is that it'll take whatever size you pass in with a grain of salt. So by default, in terms of importance, it'll try to maintain the aspect ratio of whatever whatever image you've passed in. So our image here, I think is original image is 16:9 or not 16:9. Is not actually wait, it's about 3:2, so about 50%. Okay, so like in all likelihood, if we go to turn this image into a thumbnail, this portrait, it'll likely maintain the width of the image, but it'll manipulate the height to maintain the aspect ratio. So we'll save that and we'll run the program again so you can see what I mean. So this thumbnail image, even though I passed in 300 by 300 as my tuple parameter for size, it's actually returned an image that is not 300 by 300 but 300 by 200. So I can actually check that out. Yep, 300 by 200. And it's done that so that we can maintain the aspect ratio of the image. So there are certain filters that you can apply to the method to bypass that default behavior. So I suggest that you go and visit the Pillow documentation to find out exactly what each one does. But yeah, that's basically how you manipulate images. If you have any questions on other types of image manipulations that you'd like me to look at, or perhaps other libraries that you'd like me to explore, let me know in the comments. Alrighty, thanks for watching this video on how to work with images in Python using Pillow. Don't forget to hit that subscribe button for more tips and tricks on how to work with Python. If you have any questions or suggestions, please feel free to leave a comment. See you next time.